Okay, so this is chapter 7 on sedimentary rocks. And on page 76, you should be beginning chapter 7. So this diagram shows you the different depositional environments for sedimentary rocks, and you're going to explain why sedimentary rocks are important to study and how they develop society, or how they help society as a whole. So why should a non-geologist care about a sedimentary rock? And we did discuss this in class. We derive our energy from sedimentary rocks. So natural gas, oil, those all come from sedimentary rocks. So this is one very good example of why a non-geologist should care about sedimentary rocks. Page 77 shows the classification chart for the different sediment sizes for grain sizes in sedimentary rocks. And you want to, on this page, tell me what the depositional setting would be and what type of energy, low, medium, high energy, would be for the environment of deposition for these different classifications. Okay, on page 78 is a diagram of sorting and rounding for sedimentary rocks. So when we look at detrital sedimentary rocks like a sandstone, we're going to look at how round or angular, so it's sphericity, whether it's low or high, this grain has. We're also going to look at how similar the sediments are to one another. So here you can see that the sediments are a variety of sizes, and they're also demonstrating that they're different colors, so they might be made of different minerals or different pieces of rock. So there can be a wide range of sizes in a very poorly sorted sedimentary rock, ranging to poorly sorted, well sorted, and then very well sorted. So it has to do with how similar the sizes of the grains are. So what would be the rock name that you would give to each sediment? So what would be the rock name for this sediment, for this one, and for this one? Okay. Page 79 of your notebook is an example of sediment. Okay, so here's sediment, and then this is what it would be after it's been lithified and then uplifted, so re-brought to the surface. So this is Jurassic Age Navajo sandstone from Utah's Zion National Park, a very cool place. You should go visit when you can, or if you ever get the chance, go ahead and check it out. And so this is an ancient sand dune environment, and we can see picture of the depositional setting here on the right. So this is what it would have looked like if we could have traveled back to the Jurassic. Okay. So on this page 79, sorry for the shakiness, you want to describe which features a geologist would use to determine the environment of deposition. So if I didn't already know that this was a dune setting, how would I know it's a dune setting? And then you could even provide an example of how else geologists would know what type of environment a sedimentary rock is formed in. Page 80 shows you coquina, a very cool rock made of gravel-sized shell pieces. And you guys saw this in lab. So on this page, page 80 in your notebook, you want to describe the depositional environment that you're seeing in the picture here. And then what would the rock name be? What type of rock? So what category would it fall into? I already gave you the rock name. And then what mineral makes up this rock? Hint, it's the most common sedimentary rock, and it's made of this mineral. So make sure you tell me the mineral name, not necessarily the sedimentary rock name. Okay, so minerals and rocks are different. Okay, page 81 has a picture of Guadalupe Mountains National Park, your backwoods over there in Texas, just about an hour away from us. And so the Guadalupe Mountains are a ancient reef structure from the Permian, and it is limestone making up the mountains. So tell me about the geologic history of the area. How would a reef become the highest point in a state? So Guadalupe Peak is the highest elevation point in Texas. So just walk me through the geologic history of the area here. Page 82 shows the very famous white chalk cliffs of England. So just describe how chalk forms, okay, and how this hundreds of feet high cliff would have developed. We find out on page 82. Great. So now, page 83. Describe the depositional setting for oolitic limestone made of ooids. Okay. There's a very specific depositional environment for this type of limestone, which we discussed in class. Hint, it is a very specific type of marine environment. Okay. On page 84 through 90, you are provided with different depositional environments for sedimentary rocks. So this is the environment that the sediment is being laid down in order to form the rock. Explain in detail for each type of depositional setting what the sedimentary rock would be that formed here, and then what would the characteristics be for each setting that you could observe in the rock. So for example, a beach setting would have very well-rounded clasts. It would be a detrital sedimentary rock that we would call, depending on the size, but most often it would be a conglomerate. So we would know that we would have pebbles and cobble-sized pieces, and they would be subangular to well-rounded from the beach water moving back and forth. Okay, so those are the characteristics that we would look for. So you're going to do that for beaches, caves, like the Carlsbad Caves, also sand dunes, tidal flats and lagoons, deep marine environments, shallow marine, alluvial fans, inland seas and lakes, glacial deposits. Glacial deposits we haven't talked about a lot in class, but glacial deposits are going to be very poorly sorted. So just random material that gets transported very, pretty much very close to where it originated. So it's not going to be rounded really at all. It's just going to be a big glob of poorly sorted mess. Okay, page 89, you'll see a swamp environment and landslide. So there's a very specific rock that would be called something that starts with a B here. So what type of rock would form there, and what characteristics would you look for? Page 90 gives you stream environment and a coral reef environment. Okay, page 91 lists different depositional environments, and what I want you to do is just, you have to look kind of closely, but there are labels for each of the environmental settings. So just write, you could even do a T-chart here. Put the environment here, and then give me the rock name that could form there. And there's going to be more than one rock that could form in each environment. So as long as one is accurate, you'll be good. All right, page 92. Create a legend, and a legend is just a couple sentences explaining a diagram. So create a legend for the carbon cycle. Uh-oh, I skipped a page, sorry. Create a legend for the image on sources of energy on page 92. List what each energy source is used for in the United States. So it gives you your different sources: petroleum, natural gas, coal, renewables, and nuclear power. So give me an example of what we use each of these for. You can see that we rely heavily on petroleum and natural gas, second to coal, for our energy sources and energy needs. Okay, and it gives you lots of space here. Page 93 shows you heat energy usage for the United States. So on this page, explain why there are different amounts of energy that is extractable for the 4 types of coal. So why can we get more or extract more energy out of an anthracite versus a lignite? So the BTUs per pound would be the electricity per pound of coal. So you can see that anthracite is the best coal to use to extract the most energy. So create a legend explaining why that's so. On page 94 is the carbon cycle. So create a legend, just a few sentences here. Explain what humans are doing to throw off the carbon cycle. So which step of the carbon cycle is this interference occurring at? Page 95 shows you the steps in the formation of coal. Oh, Buster! Buster's trying to help you with coal. He likes rocks too. Okay, so page 95. Create a legend that explains each step and change in the type of coal seen in the diagram. So it's giving you a diagram. Explain in words what's happening. This is dual coding of our instructional strategies. Page 96 shows you the 2 steps in lithification, compaction and cementation. So on page 96, explain these 2 factors and how would these happen geologically speaking. How do we compact and how do we cement sediment together? On page 97, our last page for this chapter. Explain here what each of the different categories are for classifying sedimentary rocks. So what are our broad categories, and then how are those rocks in those categories different from one another? And then also tell me what would be the key characteristics in a rock you'd look for when you're trying to identify them. All right, and that concludes chapter 7.